So today we're looking at the second derivative, and that is pen f double dash of x. And when f double dash is greater than 0, we know that we can find a minimum. And when it's less than 0, we know that it's a maximum. This is how we've proved a minimum and a maximum in the past. Now, what we're also going to be looking at is points of inflection, which are between minimum and maximum, and at other places as well. Okay, so if we have a look at a cubic graph, okay, that graph has a maximum here and a minimum here. Halfway between on the cubic graph is what's called your point of inflection. Okay, now we're looking at what kind of the properties of these curves as well. So if we look at this bit here, it's sort of shaped like a U shape up to a point, and we call that, at that point, we call that concave down. Okay, at this point here, at the point of inflection, what it does, it changes to concave up. Okay, now at a point of inflection, f double dash of x equals 0. Okay, so if we have a look at a graph like this, okay, and let's have a look at the nature of this graph. Okay, so here and here somewhere will be a point of inflection, and you can see here it's concave down. At some point, here's a maximum here. Now, at some point there, that changes from concave up back to concave down. Now, here will be another point of inflection. It's at the point where the gradient is at its steepest. And if you think about that, here the gradient is 0. Oops, sorry. Here the gradient is 0. Here the gradient is 0, sorry about that. And here the gradient is 0. So it gets, as you're going down here, it's getting steeper and steeper and steeper until that point, and then it starts flattening out again. Just going back to the concavity, here it's concave down, and here it becomes concave up again. Okay, what we're going to do is find the points of inflection for a graph. So we've got the graph f of x equals x4 to the power of 4 minus 4x cubed plus 16x minus 2. Okay, and we're finding the points of inflection. Okay, so we want f double dash of x equal to 0. So first of all, we find f dash of x, 4x3 minus 12x squared plus 16. And then we double differentiate it. So that becomes 12x squared minus 24x. Now we put that equal to 0 for the points of inflection. And we'll just move that up. Now this becomes a quadratic. You can either put it into the calculator. We can solve this relatively easily by putting this, factorising it, pulling 12x out the front. And that becomes x minus 2. And therefore our x has to be 0 from this bit or 2 from this bit. So there are 2 points of inflection. Of course, to find your y values, you go and substitute it back into your original equation. So if we substitute 0 into it, we'll get y equals, that's 0, that's 0, that's 0, that's 0, we get negative 2. If x equals 2, y equals 2 to the power of 4, it's 4 times 2 to the power of 3, plus 16 times 2, minus 2. 2 to the power of 4 is 16. 2 to the power of 3 is 8. 4 times 8 is 32. 16 2s are 32. They cancel out, so we end up with 14. So our 2 points would be 0, negative 2, or 2, 14. Okay, we'll just have a look at another twist on a question like that. So now we're going to have a look at, find out where is the graph f of x equals 6x squared minus x cubed plus 15x minus 2. Where is it concave up? Okay, so to do that, what we're going to do is we need to find f double dash of x. So find f dash of x first. So that's 12x minus 3x squared plus 15. F double dash 12 minus 6x. Okay. Now we know that it's a point of inflection when f double dash of x is equal to 0. Because remember when I said before, where it changes from concave up to concave down is at the point of inflection. So that means that x must equal 2. Okay, so let's have a look at when x is 2, what's happening to our f double dash of x. So we know that at that point our f double dash of x equals 0. So that's a point of inflection. Remember that it is concave up, like that, at any minimum point. So that's when f double dash of x is greater than 0. It is concave down at any maximum point and surrounding, and that's when f double dash of x is less than 0. So for this particular one, we're looking at f double dash of x being greater than 0. So look at points either side. So we'll look at points 1 and 3. So if we substitute 1 into this bit, we get 12 minus 6 times 1, which is 6. It doesn't matter what the number it is, it just means that it's positive. And if we try 3, that means 12 minus 6 times 3, 12 minus 18 is negative. So we're looking for when it's concave up, so it must be at this point here when it's greater than 0. So that means that whenever x is less than 2, it is concave up. And that's introducing second derivatives.